Hi everybody. So the lab I'm going to do for you now is Lab 9, the 7-segment LED display. Okay, so this is Lab 9 on the 7-segment LED display. And what I have in front of you here, I have this board here, which I've set up to be my output LEDs like you would have on the green logic board that we use in the lab, and I'm not going to use that today. I also have a bunch of push button switches here set up to be my input switches, and I'm going to use some of those. So these leads that have been connected here in nice rainbow colors, those are my switch inputs. And I've connected 5 volts over here on the left side. So I've got plus 5 volts and minus 5 volts to this breadboard, and then I'll connect from there to other boards as needed. In this lab, we're going to use 3 main components plus some wires. I have this module here, which is a 4114R-1, which is a set of 7 resistors. So looking at this chip, from one side to the other directly across is 1 resistor, 2 resistors, 3 resistor, 4 resistor, and so on. So it contains 7 resistors, and that's one of the components I need for today's lab. I'm going to put it in the middle of my breadboard and push it down all the way. Okay, so it's in. So connecting from, you know, this side would be one side of the resistor, that side would be the other side of the resistor. And you don't want to connect those 2 sides together, right? You want the resistor part of it to be in between. So if I want to connect to one end of the resistor, I would be here. If I wanted to connect to the other end of the resistor, I would be directly across to the pin that is directly across, and I would not connect these 2 sides together. Otherwise, I would be shorting the resistor. Okay, that's really important. I'm going to take those leads out for now. The one other element that I'm going to use today is the 74 or SN74LS247N. So that is a BCD to 7-segment decoder chip, and I'll explain to you in a minute what it does. I'm going to put it into my breadboard, and I just have to gently squeeze the pins a little bit. Okay, not too much, but just a little bit to get it to fit properly across my breadboard. Okay, and I'm pushing it down all the way. And remember, what I have right here is the byte of the chip, and so I know that pin 1 is this pin. And same thing for the resistor array. There's the little byte. This is pin 1. So I'm having all my chips, you know, sort of facing to the left, so that pin 1 is here on the bottom left. Okay, and I'll do the same for my 7-segment display. Now my 7-segment display is here, and you can see that it will display a digit if all 7 segments are lit up. Now if I look on this side, it might be a little bit hard to see. Let me put something colored in between there so you can see. On the one side I have pins 1, 2, 3 with legs. 4 and 5 are not connected at all, and then I have 6 and 7. Okay, on the other side, if I isolate one side from the other there with my little Humber lanyard. You can see that I have pins 13 and 14, but 12 is not there. And then 11 to 8 are there. Okay, so just to recap there, pins 4, 5, and 12 are not actually connected. So again, this is a 14-pin unit, and I've got 5 pins on this side and 6 pins on that side, but knowing that some of the pins are skipped, right? So this is pin 1 to pin 7, and then 8 to 14. So I am going to plug that into my breadboard as well. And I'm going to, just so I can remember where the legs are, I'm going to put pin 1 into row 20 of my breadboard, just so I can, you know, if I need to count rows to know which pins I'm at, because I can't see the pins once I push this, this unit down in the breadboard. So I know I've put pin 1 here in row 20. I can use that to my advantage there. And I'm going to make sure my pins are all lined up properly before I push it right down. There's also a little protective plastic cover on it. I could peel it off, but I won't bother to do that right now. So the first thing I want to do is get to know my components. And I'm going to look at the data sheets for my components, and I'm going to test my 7-segment display. So what I have here off to the side, I've cut out a piece of the data sheet for this 74LS247. So you can see it there, and it's showing all the pin connections. Okay, so I can see that I've got this ABCD, capital ABCD are inputs, and these lowercase ABCD, EFG are outputs. And I have power and ground, and I have some setup lines there. And so we'll talk about that a little bit more. Before we get to that, I want to test my 7-segment display. Now my 7-segment display, I've got a little picture of it here. You can see that the segments are labeled. So A, B, C, D, E, F, and G. And that corresponds to the little A, B, C, D, E, F, G that was on the pinout for the decoder. So the decoder already knows the position of these lowercase letters, lowercase letters, and the decoder knows how to illuminate the right segments to make the digit we want. That's why it's going binary coded decimal, which is 0 to 9 digits, to 7 segment. So it's taking a binary number that we put in, 0 to 9, and converting it to whatever segments need to light up here to make the decimal equivalent of that binary number. Okay, so we'll talk about that a little bit more too. But what I want to do first is I want to test this 7-segment display, and the lab is telling us, I don't have a data sheet for this part, although there's a part number on the side, so I probably should have looked that up. But the lab is telling us that that this 7-segment display is common anode, and so I have my little reminder down here because I get left and right and things like that mixed up. So I'm reminding myself that the anode is actually the positive side of a diode, and the cathode is the negative. And so I know that I want the anode to be more positive than the cathode. So if this 7-segment display is common anode, it means that all the segments are getting power. In order for a segment to light up, they have to get a ground. Now, that has to happen through a resistor so that we don't burn out any of our segments. And what we're going to do, and what you're going to do actually, is fill in this little table that's in your lab to say which pins are lighting up which segments, right? I know that I have this pin arrangement, but I don't know which pins light up which segments. And so we're going to experiment and fill in this table and figure figure that out, okay? So how we're gonna do that, now your lab says to use a 220 ohm resistor. I'm not gonna bother with a 220 ohm resistor because I've already got that 150 ohm resistor bank chip sitting there in my breadboard. So I'm just gonna use one of those resistors, okay? So I'm gonna connect to one end of the resistor and have that as my test probe that is going to go to my 7-segment display. And I'm going to ground the other end of the resistor. So essentially, I'm going to put it in the blue rail of my breadboard here, which I'm going to ground. And so essentially what I'm doing is I'm going to give power to the 7-segment display, and then I'm going to go along to each pin, giving it ground and see, but not pin 3 because that's already power. And I'm going to see what happens, okay? Which segments light up. So let me give power to this breadboard. I'm going to connect a red wire here over to my other breadboard. And I'll connect a ground here. And I can actually connect the two sides of my breadboard together if I want. I'll at least connect the two power sides together so I can have power on both sides. Okay. And actually, since I want ground to be down here, I had better do that as well. Okay, so, and you notice actually on my breadboard, this breadboard here, I have these little jumpers going across the breadboard. You can see that the line indicating red and blue rails here on the breadboard is broken, meaning that the power rails on each half of this breadboard are not actually connected. So I've joined them. Whereas on a breadboard like this one up here, you can see that that line runs straight across, meaning both, like, that the power rails run all the way along. On one like this, it's actually split in the middle. So, you know, keep an eye on what kind of breadboard you have. So what I'm going to do now, I've got my resistance in there, which is important so I don't burn out my 7-segment display. And I've already been told that pins 3 and 14 are power. They're common anode. So I'm going to connect the 3rd pin of this, which is there. I'm going to connect it to power. Okay, and just kind of tuck it out of the way there. And I'm just not going to measure it at pin 14 because I already know that that is also common anode. So in filling in this table, I've already wrote in that I've got common anode there. I am going to fill in the first value for you, and then I'm just going to do the testing, and you're going to fill in the other values. So looking at this, I want to know pin 1 lights up which segment. So let me turn my power supply on. So I'm connected to the fixed 5-volt output of a power supply. And what I'm going to do now is take my little test lead coming from my resistor, and I'm going to connect it to pin 1. And you can see that segment, if we look at our little diagram here for the 7-segment display, that is segment A. Segment A is lighting up. And the funny thing is, it looks kind of green on the video with the lighting. It's actually red in real life. So in my little table here, next to pin 1, I'm going to write that lit up segment A. Okay, so segment A. And then I'm going to move on to pin 2. Pin 2, this segment is segment F. So I'm going to fill in my table, segment F. Okay, see what I've done there? Segment A, segment F. So now I'm working my way around, filling in my table. Pin 3 we know is common anode. We know pins 4 and 5 are not connected. So I'm going to skip those. Pin 6 is DP2, one of the little dots. Pin 7 is segment E. Pin 8 is D. Pin 9 is DP1. Pin 10 is segment C, right here. Pin 11 is segment G, which is that middle segment. Pin 12 is not connected, so it makes sense that nothing happened there. Pin 13 is segment B. Wait. Yes, that was 13. And 14 we know is the common anode. So I have to remind myself that 12 was not connected, and then 13 was with B. So now I've filled out my table. I know which of these pins will light up which segments. Okay, so now I'm going to just take that apart for now, and I'm going to turn off the power, and I'm going to think about how I'm going to wire the next part of the circuit. So what I want to do now is connect the decoder to the resistors and the resistors to the segment display, because I don't want any of the segments to burn out. So what I'm looking at here is this diagram from your lab book, where I have to connect from the decoder to the resistor network to the 7-segment display. And remember, the decoder's outputs, these A, B, C, D, E, F, G outputs from the decoder, they're meant to wire to A, B, C, D, E, F, G of the 7-segment display. So that if through these binary inputs, if you entered, say, the binary number 1, segments B and C should light up to make the digit 1. Okay, and so this decoder knows to light up B and C. Now there's bubbles on the output of this diagram here indicating that this is an active low chip, meaning the line that it's considering active, it will give a low signal to. That's exactly what we want, because remember, this 7-segment display already has a common anode connection, which is power to pin 3. And what we want to do is provide a low output on the other side of these resistors. So this is going to work fantastic. And what I need to look at now is the actual pinout for this chip, which is here, right? I've got my pinout there. So it's telling me that I need pin 16. This is a 16-pin chip. Pin 16 goes to VCC, which is power, and pin 7 goes to ground. So I've got some wires here. I'm going to, I may bend them a little bit. I'm going to put pin 16 to power and pin 8 to ground. Okay, so that is connected. Now, the LT pin and the RBI pins, which is 3 and 5, we want to connect those high, okay? And I'll show you something with the LT pin, but first, let me connect RB high and connect the rest of the circuit as well. So for now, I will also put pin 3, which is LT. I'm going to set it high to my red rail. I've got my red rails on both sides here working. And I'm going to set pin 5, also high, because that pin is a setting that we're not using and it's active low, so we want to set it high to get it out of the way. Now, pins capital DCBA, those are our inputs, and D is our most significant bit, and A is our least significant bit. I'm going to use my switches here for the inputs. So I'll take the last 4 here. So I've got purple, blue, gray, and white, and I want them to be, you know, most significant bit here, least significant bit there, so that when I'm pressing combinations, I can press combinations that make sense to me. Unfortunately, I don't have slider switches. I only have push button switches, so I'm going to have to hold them down, but that is okay. So I want this to be pin D, which will be 6 on my chip, and I have to remember this is an 8-pin chip, so 8, 7, 6 is here. C, purple wire is going to be C. That is going to pin 2. Gray is B, that is on pin 1. And my white wire here is going to be pin A, which is my least significant bit, which is on pin 7. Okay, and remember this is a 16 pin chip, so pin 8 is the ground here for this one. The other ones are 14 pin chips. Okay, so that's the inputs connected. Now I need to connect the outputs. Okay, so I'm going to connect the A, B, C, D, E, F, G outputs of this decoder to my resistor bank, and then from my resistor bank to my 7-segment display. And remember that I am not going to tie the 2 sides of the resistor bank together, because that would short out the resistor and probably burn segments of my 7-segment display. So it makes sense if we say, you know, A, B, C, D, E, F, G, right? Just go in order all the way along so that we can remember which is which. So can I color code? I'm just looking at my selection of wires, wondering if perhaps I have enough wires to color code this situation. And I think maybe I do. So red is going to be for A, and A is going to pin 13. So we have 16, 15, 14, 13. That's here. And so I will also use a red wire representing A to go from the other side of this to segment A. Now, according to my chart, segment A is on pin 1. So that's going to be here. Okay, and remember, wire color doesn't really matter. It's just helping me stay organized here. Okay, so this is going to be output B, which is on pin 12. And that is going to go segment B, according to my previous chart, is on pin 13 of this, which will be there. And output C, pin 11. And that's going to go to pin 10 of my 7-segment display. So 13, 12, 11, 10. Okay. And then output D is on pin 10 of the decoder, and it's on pin 8 of the 7-segment display. Okay. Moving along, I have E, which is pin 9 of the decoder, and E is pin 7 of the 7-segment display, which is 6, 7. Okay, and so notice I'm connecting my decoder all to this side and my 7-segment display all to that side. So I've always got the resistor in between. And now this is going to be F, which is on pin 15. And then F is on pin 2 of the 7-segment display. And what am I missing? G. Okay. Pin G is pin 14 here, and G is pin 11. Okay, so I've connected everything, and now I know it's a little bit hard to see with all those wires, but now what I'm going to do is I'm going to fill in the truth table. But actually first, let us check the all the lights using the light test input. So I'm going to turn the power on. Nothing should happen at first. Oh, I'm set to a 0. Does that make sense? Actually, that does make sense because right now all my inputs are set to 0. That makes sense. Okay, because remember I'm using these open push buttons, and I've set them with pull down resistors. So with all the buttons open, I'm actually getting 0, 0, 0, 0 as an input, which gives 0 as an output, which is the digit we can see there. I'll try to arrange these wires so that you can actually see the digit. Might be a little bit tough. I'll keep telling you what the output is. So now the lamp test input, which is on pin 3, according to our pinout diagram, I've got it tied high right now. If I tie it low, which makes it active, notice that all segments, you can see there, all segments now, even the middle section, have turned on. And so the lamp test is testing all segments, and they all do come on. So I'm going to put it back high to get it out of the way. And now notice, actually, if I put the lamp test high, I can push any buttons, and it's not affecting my output. My output is still looking like an 8 because it's turned all the lamps on. Okay, but I'm going to take this pin 3 of the decoder lamp test and put it back to high so that it's out of the way. And now the segment should light up according to the binary or the BCD input that we give it. So let me hold that like that so you can see the digit. So if I have my most significant bit here, my least significant bit there. If I press this button, let's see how I can press these without getting in the way of the camera. I have a 1. Now it's a sideways 1. Keep in mind that the top of our digit is this side is the top. So there's a 1. There's binary 2, and it shows digit 2. I'm pressing 2 buttons now to get binary 3. There's binary 4. These 2 buttons would be binary 5. And you can see I do have 5. And then 6. And then if I do 3 buttons, I should get 7. And then 8. Uh-oh, my wires are in the way. And then if I do 8 and 1, that's 9. Now, if I go to do 10, I only have 1 digit. So notice I don't get a 10, I get this little symbol, right? And if I put in the binary number for 11, I don't get 11, I get this symbol. So there's 10, and there's 11. Okay, and there's 12, and it's hard to press multiple buttons with one hand. There's 13. There's 14. And if I press all buttons, which would be 15, let me do that with 2 hands. If I press all buttons for 15, that's what you get. Wait, sorry, that's what you get. So all buttons with 15, all the lights have gone off. It's hard for you to see that right now. Okay, so I'm going to press all those digits again so that you can see the outputs. Now let me just, that's not gonna work. Let me just hold these wires down together so that you can see the output display while I press the buttons again. So there's 1. So there's no buttons pressed, 0. There's 1, 2, 3, 4, 5, 6. I'm doing 3 buttons here for 7, 8, 9, 10, 11, there's 11, there's back to 10, there's 12, 13, 14, and then 15, 15 turns all the lights off. Okay, so you want to listen to that carefully and see what you get. And notice that for 0 to 9, you were getting the digits that you expected, but once you got to 10, you got something like that. 11 was that. There's 12, 13, 14, and then 15 is all off. Okay. So you want to go through lab, record those in the table, and the table's asking you to record not only what is displayed, draw what's displayed on the digit itself, but say which segments are are active, so which segments are lit up, okay? And that is all you need to know about Lab 9 with the 7-segment display.